In this session, I'm thinking of revisiting the data structure that I've been using for turn ordering. Currently, I've been using a view over some backing storage, but I'm thinking now of using a queue. I believe I have a queue. Basically, it's just this ring buffer here. So it's going to be a ring buffer of S64. So entities is no longer going to be struct. I think this just goes away. This is just going to be a view over entity like this. And turns is going to be a ring buffer of S64. And we need to go into initialize and make sure we set up turns correctly. So we don't need to set the backing storage because that's handled for us already. That's gone away. Ring buffer push. And again, pointer to GS turns, and then the value, which is just it. Here, we just call new array, which is going to use something through the JI allocator. In arena, here, I do have a JI arena allocator proc. It's just in storage allocator. This gets a pointer to, this is going to be m.persist. And then when we initialize, we will do a comma, and say allocator equals assistant storage allocator. So entities, components, and I guess we'll pass in turns here. We're going to be pruning here. So this is going to be a pointer to a ring buffer, S64. Now the turns index, we had to do this whole like while true thing and turns index because we were mutating the view that we were working over. Here we need to delete something from the queue. And because the queue is contiguous storage, it's going to be, and it's also ordered, right? Ordering matters in a queue. We're just going to have to do kind of a slow delete, which is delete an element and then shift everything down. Yeah, I'm just going to introduce a delete at here. So ring buffer and then index, which is going to be an S64. And the bool will just indicate if the index is invalid, for example. But now we need to get the true index. Okay, so I think we have to mask this, right? True index is going to be, call this current, and call this next. +1, okay, so current, it's the RB data next. That shifts down by 1. Test.jai has test for the ring buffer. Delete did not work, right? Because we have a bug. We need to reduce the size by 1. rb.write minus equals 1. Test delete at. Yep, and that works. It's not a very thorough test, but I think I do cover the case where we have wrapping via masking and whatnot. Let's come back to entity here, because now we will be calling delete at. Yeah, I guess back in the test, I should also make sure that I can correctly delete the remaining element as well. Test that again. So we're going to compile that and then build it. Uh-oh, it's looping forever. And then we'll say index, which is going to be 0. And then size is 1. Oh, wait. What does size return? A U64. Uh-oh. Return to U64. So this underflows. I guess we should probably pass to S64. And that's going to be very important. Size probably should be an S64. This guy. So the unsigned stuff is important in the struct definition for the ring buffer. But returning an S64 here is going to break a bunch of my other code currently. But that's probably the right thing to do. The better thing to do, just to be more consistent with the JI API. Now for this guy here, we still need to make an entity view, make an entity view with turns index. So we're going to need to peek, I guess. We need to peek, and we don't have a peek either. Peek at. It's going to be index, which is another S64, and we return a T. This needs to actually be like a bool or a T because we need to do this guy here if we are empty, or the index is less than 0, or the index is, gotta get size again. Okay, now we need to go back to the tests, and that is peek at, test delete at, peek at, so that fixes that up. Then we run this, and that works. Okay, so now we have a peek at, so get rid of that, get rid of that, get rid of that. Just actually have to call delete at, ring buffer, delete at, and this should always pass. That should always work. Delete at works by, so this is going to be turns, and the index is just going to be it. So we no longer do turns. We now say for 0 to, it is going to be game state dot turn. It's going to be size, right? Ring buffer. Yeah, this is going to be weird because in attack, if we reshuffle the indices of the entities, we're going to need to go into the turn queue for the ring buffer. And we're going to need to modify. So we're going to get the entity index is okay. And the entity index is ring buffer peek at the PS turns 0. Just peek at the head basically. And then here, if somebody attacked, we shift. Say ring buffer shift, and this is PS turns. And we just throw the value away. Shift works, but really we don't want to shift. We want to delete at. But the delete at is expensive because delete at shifts everybody down. This to-do explains my quandary right now. So a shift actually works, but it's just coincidental. So attack now no longer has access to the turn queue. So we'll probably need to pass in entities, components, and turn. Let's go into delete non-player entity now. This guy here is just a simple deletion. However, we do some special logic. Because we deleted an entity from the entities view, the indices of all of the entities whose index was greater than the index of the entity we just deleted, they now shift down by 1 because those indices have moved toward the head of the ECS. There should not be a concept of a head of an ECS, but that's just how mine is implemented. We can't really get a view over the way I've implemented the ring buffer. Now here's the question, I guess, do I implement a for expansion? Array find. We looked at the implementation of this. This also is just head to tail iteration. So we're gonna have to do that ourselves. So we're gonna need to loop through the entire collection. We are currently only ever updating the entity indices at the position that we found the guide to delete and afterward. And that's a nice latent defect. Then what we say is if the value is the entity index, then we have found a match at position it, the iterator, which is gonna go from 0 to size -1. And then we break from here. And now we do another loop through this guy, and this loop is going to do all this kind of logic here. Not found is -1. If found at is not equal to not found, then we do this guy here, ring buffer, delete at, turns, and found at. And then we need to loop one more time through and apply this whole logic here for 0 to ring buffer size turns -1. And if the value is greater than the entity index, then we need to reduce the value by 1, and we need to set that at iterator. So, okay, we have all this stuff here. Get rid of all this stuff. Now we need to implement set at. We take push here, turn true, RB data data, mask RB right, so this guy plus cast to U64 index is the value. We call it V elsewhere, so we'll just call it V here. It's not X, so that's the thing, it's not gonna be right. That was almost a bug there too. It's gonna be read. But that makes sense because read is the head of the queue. Now back to testing again. And duplicate this test here, get rid of all this stuff. And we're just going to set. So we peek at RB, it's going to be 1, and we need to make sure the value is equal to 4. Go, run this, that passes, so I think we're okay. And then we have this guy here. Repopulate the turn queue if we have empty the queue. We just say ring buffer push vs turns it. And peek at number sign mismatch, 1 to S64 given U64. Wait a second. So ring buffer.size is going to return a U64. Oh, crazy. Wait. This actually needs to be an S64, right? Because we're doing the whole -1 thing here. It just keeps getting me, dude. This keeps getting me. Okay, that builds. And okay, this is exactly what I expected. We attempt to move somewhere and we have immediately died. So this is the exact same bug I keep running into all the time, which is I will delete it, turn 0. That will shift everything up in the queue. And so now there's a new guy in position 0, but on the next pass through the iteration, we're going to be iterator 1. So we now skip that person. He's going to be left in the array. So prune turn queue, 0 to ring buffer. Oh, see, it got me again. This needs to be cast. Okay, that's a really big foot gun I need to fix. Let's delete. He did not advance. It's not immediately clear to me whether using a queue data structure is better than a view, because the view has gotchas and the queue has other gotchas, and also working with specifically with a ring buffer as a queue, it's turning out to be a little bit expensive because of the kind of operations we need to do on the backing storage. And so actually having something like use links or something, actually have contiguous storage, but like implement the linked list and contiguous storage and just jump over holes or something like that. It's possible I'm not leveraging the ECS as extensively as I should be leveraging it. Oh man, it's so simple. Because I called it index, and I'm like, what's this thing called? We have a magic keyword called index. It's not called index, it's called it. This is a delete non-player entity. I'm conflating this. They might not be in the turns queue, which is fine. We need to return true if deletion succeeded, if deletion from the ECS succeeded. And then what we say is this value does not reflect whether any changes were made to turns. If the index is invalid, we return false. So otherwise, we just return true here. Okay, I think we just need to separate this out. If he is in the turn queue, we do the deletion. Regardless of whether we do the deletion, we have to go back through the turn queue and modulate the entity IDs. Bring this out here, get rid of this brace, and I guess realign kind of this stuff. Let's run this, and okay, now he's gone. 1, 2, okay. I think that was the last bug there. Have a good rest of the time, wherever you guys are, and peace.